Hi, my name is Penton Miyuki and today I'll be talking about my EM3 assignment. Today we're discussing Euler's method. This is a numerical way to estimate the solution of a differential equation, and here is the formula. yn plus 1 refers to the next value of y, yn refers to the current value of y, h refers to the step size, which moves along the x-axis, and fxy refers to the slope of the current point or dy over dx. N refers to the step size number, which increases from 0 onwards. We can see that x0 is equals to 0, y0 is equals to 1. From the question, we know that dy over dx is equals to x squared plus 1 over y, and the initial values of x and y axis points are y is equals to 1 and x equals to 0. And the step size that we are using is h is equals to 0.1, meaning that we're moving forward along the x-axis in the increments of 0.1. We continue this process until we reach the value x is equals to 1, because the question requires us to find y when x is equals to 1. To find the exact value of y, we solve the differential equation using the separable method for the first order ODE. This is the equation that we were given, and then we separate it and then integrated both sides. From here, we obtain the general solution. To find the value of the constant c, we sub x is equals to 0 and y is equals to 1. From here, the value that we get is half. We then sub c back into the general solution to obtain the particular solution. Finally, to find the final exact value of y, we sub in the final value of x, which is given in the equation, x is equals to 1, where we get the final value of y here. To find the approximation value of y, I use Excel. The highlighted values in the y and x columns represent the initial state given from the question earlier. I use the formula xn plus h, which is the current value of x plus the step size, which in this case would be 0 plus 0.1. Using the Excel's drag down function, I filled the values of x up to 1. To calculate y, I apply Euler's formula. Yn, which is the previous value of y, which in this case is our initial value of 1, plus h, the step size of 0.1, times the obtained value of dy over dx, and drag it down. By using the formula xn, current value of x, to the power of 2 plus 1 over the current value of y, we get the value of dy over dx and then drag it down. And here is the final value of y. To further explain, I repeat all these steps but change the value of h to 0.05. The final value of y that I obtain is here. To find the value of the approximation error, we use the formula exact value minus the value obtained using Euler's method. I applied this for both cases, h is equals to 0.1 and 0.05. We can conclude that the smaller the step size, the smaller the approximation error. This means that as the step size decreases, Euler's method approximation becomes more accurate and gets closer to the actual value of y. To give a visual representation on how Euler's method works, I use Desmos to generate the curve for the example y is equals to x squared plus 1 and compare it with the curve with Euler's method. These are the actual plots of y with the increment of 0.2. I calculated the estimated values of y using the Euler's method. First, we find the derivatives of x squared plus 1, which is 2x. Then use the Euler's formula by subbing in all this information. Here are the step-by-step working to find the values of y. With the values that we obtained earlier, I use this to plot and draw Euler's method curve. As you can see, there is a slight difference between the actual curve of the Euler's method due to the inaccuracy of the method. Euler's method doesn't follow the curve exactly. It creates a series of straight line segments based on the slope at each point, so causing a visible gap. That will be all for my EM3 assignment. Thank you.